Hey, I want to show you why using Sigmoid as an activation function can cause vanishing gradient. So, say we have some inputs x1, x2, x3, and that's being fed into the layers of z, where z contains weight 1 and bias 1. And we're taking the activation function of z, and that's going to be sigmoid actually, so sigmoid of z, and then we're going to go to another layer, right? So basic neural network. So we just go to our second layer, and then we take the sigmoid uh, of z1, so called the z1, where z1 has weight 2 and bias 2 as variables, right? So now x is being fed into this, right? Obviously. Um, Now imagine we don't stop here, right? This keeps going. So this part, right? We just keep passing these on. So now this will be passed into another layer, right? This may be Z2, and this has weight 3 and bias 3, right? And this part, we keep doing this over and over again, but we're taking the sigmoid activation function also over and over again, right? Now the max derivative of the sigmoid function is 0.25, right? And in order to get the derivatives of our weight, right? Weight, that's gonna be our x by the derivative of our z's, right? And derivative of w. So as we keep going back and forth, back over and over again, and derivative of z layer, right? So this may be z2 second layer, z1 first layer, right? So as we keep going back and back, so let's say x times the derivative of our z2, right? And that's derivative of w2, right? And derivative of w1 is x, I forgot to put an equal sign there, is x times the derivative of z1, right? And imagine we keep going back and forth and back and forth. Our derivative of z's are gonna keep getting smaller and smaller, right? Because imagine the what's it called? We keep taking derivative of z's, right? And if you remember how derivative of z is okay, sorry, I'm back. And if you remember how the derivative of our z's are calculated, of our activation, of our inputs or outputs. Sorry. So that's gonna be some weight layer, right? Times the derivative of the z after, right? So this may be 2, right? And this may be 1. Right, so as we keep going and we do the derivative of z2 is equal to some weight layer times the derivative of z3, the third layer, right? So as this multiplication continues to occur, right, and then so actually let me do this. So derivative of z2 is equal to some layer weight times the derivative of z3, right? So this becomes 0.25. Alright, yeah, 0.25. Right, and then we're multiplying this by the derivative of this. Right, so it's just gonna continue, and then this is gonna be even a smaller number. So we're gonna keep getting smaller and smaller and smaller numbers. So when we get to say z1, right? Say we get to z1, and we're optimizing our weight 1, right? Weight 1 minus a, which is learning rate, times dw1. At this point, and if you remember, dw is like this. At this point, after doing this, like, let's say 10, 20 times, we have 10, 20 layers, right? Or even 2, 3 layers, right? Our derivative of our weight is going to be very small, right? This is going to be very small. So we're going to take extremely small steps on our gradient, right? Very, very small steps, and it's going to take thousands, tens of thousands, hundreds of thousands iterations to get to that final point.